This conference will now be recorded.
Hey all,
And,
good
good
morning.
morning, Naveen sir. Naveen sir.
Good morning.
Sir, could you please teach little bit slow now?
Yeah.
Okay.
So, yeah. Do you have any gap in yesterday's session?
No, but actually, I felt like you are going to fast teach little bit.
Okay, sure.
Yeah.
So basically, the same example, the same practice we do on every day, right?
Yes, yes,
You
yes.
will realize
I
it by end of the session. But yeah, let me go a little bit slow. I thought yesterday we ran fast because we went through advanced concept, right?
yes, yes.
Completely advanced one. Yeah, it might take some time for you also to adopt it. Yeah, so let us start. We are already late. Okay, so till now we understand about our IOC containers, how to start them, and we understand about dependency injection, which we have setter and constructor based. And yesterday we learned one more, that is auto wired dependency injection using auto wired, and we understand about stereotype annotations, stereotype stereotype annotations like at the rate, controller, component, service. Just a minute. Oh, yeah. Service and repository. These all are the stereotype annotations that we have. These annotations are for creating objects of your classes by scanning your packages. Generally, your IOC container will create objects by reading XML. Now that XML based configurations to avoid, right? We choose this stereotypes. So when you use stereotypes, automatically your classes objects will be created by scanning them. And we understand life cycles also, how to manage life cycles. Okay, how to manage life cycles. Okay, today I'll give a interesting topic. We'll see a interesting topic. Okay. So earlier, while discussing about features, we said Spring application is lightweight. Okay, so in interviews they might ask this: why Spring application is Spring lightweight and and we say loosely coupled. Loosely coupled. We say Spring is lightweight and loosely coupled. Why it is lightweight and why it is loosely coupled? So when we say a application is lightweight, when we say it is lightweight means when it is not having much dependencies. So consider you build an application using some other API or framework. You build an application using servlets, application using servlets plus EJBs. You build your application using servlets and EJBs. When you do this, you need to deploy your application on an servlet container and EJB container. You need servlet container and EJB container, which provide by application containers. Application containers, like you need to use WebLogic or WebSphere. JBoss. There are many application containers like WebLogic kind of application server you need to use, and there are many dependencies from that server we will use, like for deploying it and for managing it. We use EJB container support or our servlet container support. So when you have that so much dependencies for your application, when you have third-party dependencies, right, many dependencies, your application will become, a heavyweight. Your application will become heavyweight, which because is having many other container dependencies. So when you build your application using the servlets and EJBs, you need to extend lot many classes, and you need to do lot many compilations and deployments. So your application is a kind of uh, you know uh, tightly coupled with that APIs and as well as heavyweight, because you are going to use a lot of application server features and application servers. But when it comes to the Spring, if you build your same application, if you build the same application, right, using Spring, your same application by using Spring, if you implement it, Spring doesn't require any special container here. As we discussed, Spring doesn't require any container here. If you build your application using Spring, it doesn't need any special container like Servlet container or EJB container. You can run your Spring application on IOC itself, your Spring IOC itself, so that you are not having any container dependencies. You can say your application is lightweight in terms of dependencies. It is lightweight. And when we should call your Spring application is loosely coupled. Spring is lightweight because it is not having much dependencies. But will it become loosely coupled by default, your Spring application, when you build it? No. You need to apply this to your application. You need to make your application loosely coupled. How you can make it, and what is meaning of this loosely coupled? So loosely coupled means what? When you implement your application, right? When you implement your application is combination of many controller classes, service classes, and the repository classes. Your application is combination of all these classes. Your application is combination of all these classes. Just give me a second. Sorry. Yeah, your application will have many classes, many controllers and service classes and the repositories, many repos. Okay, consider you have many classes. Okay, many classes, many controllers and services for your application. Yeah. Now here, if these classes directly depend on each other, right? Here, if you directly couple these two classes, this controller and service, directly if you couple it, I mean permanent kind of fix, if you do permanently, if you couple both of these layers or these two layers permanently, if you fix them in future, whenever you want to change one layer, that will affect the another layer, which means considered here your controller class name is A, your controller class name is A, and your service class name is B, and your repository class name is C. We know using dependency injection we can inject them. Using dependency injection we can inject the C class into B class and B class into A class. Correct. So in A class I want B class, so if I put B class name here and B class reference with a setter method or constructor, I can inject it. Okay. And the same way B class is having C class dependency. So if I create C class dependency directly here, and if I put a setter method using dependency injection, of course, I can inject my C class object into B class and this B class object into A class. I can able to inject it. But in featured, if you want to discontinue with it, okay. So I got a new requirement and new technology or new feature. My repository, I don't want to use. Considered here you use JDBC style. Here you use JDBC style. So new framework came into the market like ORM. I want to use ORM and I want to discontinue this class. I want to completely delete this class. So whenever you got new technology or new thing, and when you discontinue, when you want to discontinue it, when you delete this C class, what will happen? As this C class dependency directly we are using here, right, in this class, whenever you remove this C class from your application, still your B class is having dependency of C class. So this B class will throw some errors. Here you will see some error messages. This class will throw some errors. It will throw some errors. Same way, here you use some transaction features, some features you use. In feature, if you don't want to continue with it, if you want to remove it, okay. So here the case is now I don't want to delete this repository. I want to delete this service. I want to delete this service B class, okay. And whenever I delete this B class, now B class dependency I have directly here, right? I have B class dependency directly here. My controller class will get many errors as your B class dependency you are directly using here. So wherever you are using B class and wherever you are calling B class methods, in all that lines you will see errors. So you implemented a application using Spring and you used Spring features also. Still you are making your application layer classes tightly coupled by mentioning this class name directly here, or by mentioning this class name directly here, you are making that two layers tightly coupled. When you use a class name directly in another class, you can say that two classes are tightly coupled. In a simple word, when you use one class name in another class directly, you can say that two classes are tightly coupled. So when it comes to the MVC, in MVC, generally we inject DAOs or repositories into service layer. So in your service layer, don't use direct DAO class names. This is my DAO class name C. You should not use your DAO class name directly into your service class. And okay, you might ask, without using this class name here, how I can call this class methods? There is a way that we will discuss. Okay, and here I have a service class, and don't use this service class name directly into your controller. You should not use this direct class names here. If you use that way, then your layers will become tightly coupled. These layers will become tightly coupled. A will become tightly coupled with B. B will become tightly coupled with C. Instead of this, right? Java is having beautiful feature called runtime polymorphism. Okay. For now, just park this concept aside. Okay. Let us see the core Java concept. We have a concept name called inheritance. In our core Java, we have a concept name called inheritance. Inheritance. Inheritance concept. So as per this inheritance concept, there will be some parent and child mechanism. In inheritance, we will have the concepts called parent and child. We have parent and child concept here. We have parent and child concept here. So what is parent and what is child? So parent means what? If you extend or implement any class from any other class, if you extend or implement if your class from any other class, you can call that extended class as a child, and from whatever class you are extending it, that class as a parent. Consider here you have a interface. Consider here you have a interface, okay, interface fruit. I have interface fruit. public void taste. I have a fruit interface which is having taste and price. Consider you have a fruit interface, two methods, or weight, price, or quality, price. Consider you have a fruit is having price and quality. These two are interface methods. As you know, interface will not have any implementation. Okay, so mostly always interface will become parents, because compulsory somebody should extend or somebody should implement it. So always interfaces are parents. Always interfaces will be parents. Always interfaces will be parents, because they must extend somewhere. They must extend and implement somewhere. So I have a fruit here, and this fruit you should compulsory implement it. Class something apple. Apple implements, as that is interface, we need to use implements keyword, and you need to implement it. Fruit interface. So compulsory in your implementation, you have to provide implementation for fruit interface. For your fruit interface, you need to provide implementation here. So here I have an interface. For this interface, I need to provide implementation. So you need to provide implementation here. So I'm implementing it using Apple. Apple must need to override the two methods, public void quality. One method you should override, and you need to implement it. You compulsory implement it. If you don't implement, then your class will become abstract class and price. So you have to provide some implementation here. You have to provide quality implementation and price implementation. So now your class is usable. You can use this class. You can't directly use interface because it doesn't have any implementation. So interface will have only signature, method signature. Only we will have method signature, no implementation. So implementation we do through classes. So here you will provide implementations. So here you can call this as a parent. As we are implementing here, you can call it as parent, and you can call this one as child. You can call this as child. Okay, so fruit is a parent and apple is a child. So we need to follow this mechanism in Spring implementations. While implementing your application using Spring, you need to follow this mechanism, parent child mechanism in Spring. I'll tell you why. The reason is, so now here I have this parent fruit, and this is apple is a child. So to create apple class object and to call apple class methods, you can create like this: apple a equal to new apple, and you can call apple class methods. Correct? If you want to call apple class methods, quality and price, you can create object for apple class a dot quality and a dot price. We can call that methods. Can't we call? We can call it, right? We can call it. So I have some class client. I have some main method here. Under my main method, I'm doing this. Okay. So here I have a main method, and here I'm creating apple class object, and I can call apple class methods. So this is one way of creating object and calling it. You can do this in another way also, right? As we have parent and childs here, instead of, see, if you see here this client class from this example itself, here if you see this client class itself, client class is tightly coupled with your apple class, as you are using apple class object directly here, as you are using apple class object directly using here. Instead of doing this, you can create your object this way. Fruit f equal to new apple. This way also you can create object, isn't it? We can create, right? We can put our object, child class object, into parent class reference. This is also possible. So using this fruit class parent reference also, you can call the implementation methods, quality and price. This is also possible, right? So you can create object directly using your apple class and you can call methods. You can create object by using its parent class reference and child class object and you can call these methods. Both are same, both will perform the same, but here this statement is having some benefits. If you go with this statement instead of this, right, instead of this approach, if you go with this approach, there are some benefits. What are all that benefits is, in case if you don't want to use apple in feature, if you don't want to use this apple, if you don't want eat apple, if you don't want consume apple, you can implement one more class here, class mango, implement from fruit, and you can implement that again two methods here. You need to implement the again two methods here, quality and price. Implement these two methods here, and in future whenever you don't want to consume it, right, if you can able to make this statement also something dynamic. Okay, if you could able to create this object and pass here new mango, you need not to change the subsequent lines of code. So just you need to replace this here. So this instance creation only you need to replace, so that what will happen, this remaining lines of code, whatever number of lines remaining you implemented, right, that lines you need not to change. If you could able to make it dynamic, okay, I'm not talking about static here. If you can able to make it dynamic, the child class object, if you can able to pass dynamically your code, whatever the code you implemented here for consuming this fruit, that code is independent of implementation. You can pass mango here in future. If you are going to provide new implementation like banana, you can pass banana here, whatever fruit it is. But if you go with the first approach, if you create apple object and directly if you consume apple, you always need to consume apple only. You cannot consume mango or you cannot consume banana. Okay, so in Java it is possible that you can put parent class reference is equal to child class object. This is possible. Let me give a simple core example, a simple core Java example to realize what is the benefit with this parent child object mechanism. Java project, a simple core runtime polymorphism. I'll show you what is runtime polymorphism. So I'm just following this mechanism. Instead of having direct implementation, I'll create an interface first and provide implementation then next. Root public void quality and price. Okay, I have a interface, fruit interface. For this interface, I need to provide implementation apple implements fruit interface. So you compulsory need to override the two methods, quality and price methods. and quality. Something grade A quality something. Okay. So now wherever you want to call this apple, right? I'll write a class, client class, main method. What I will do here, I'll use scanner just to read name. Okay, scanner. System.in just to read input. Scanner dot next line. Enter your class name. Okay, I'll read one class name here. String class name. I want to pass one class name here. Right, how to use scanner? It will ask enter class name. I want to pass class name to create object at runtime. Okay, so you know how to create objects at runtime, right? Class dot for name. I'll pass the same class name. So this will create object. So that object I'll get it into fruit. Fruit is my interface. Into this interface I can pass any class name. Any class name I can pass here. Okay, class dot for name dot new instance. It will create the object. Let's throw some exception. Now I can call this fruit class dot price, fruit class dot quality. You are getting right what I'm doing here. So I'm doing this statement only. Fruit f equal to new apple. The same thing I want to create dynamically. Okay, let me comment this. So I have this statement, fruit f equal to new apple. Run it. So price and quality I'm getting it. But if you see here, the client class, whichever is the client class, this client class is directly depending on, though we are using interface reference equal to implementation object, this class name directly I'm using here. So in future, if I provide new class, so I'm a customer, I want to eat banana. So banana also implementation we have. Banana implementation we have from fruit interface. I want to consume it. I want to consume banana still. Okay, grade A, grade B, something I have. So here I want to consume banana. When you want to consume banana, what you need to do as a client, here you need to change the class name. Means at compile time only, not at runtime. You need to edit your class to consume banana so that you could able to execute it. So for now we are using apple price 200 and the grade is A. So when you want to change it to banana, you need to change it here. You need to go to your class and there you need to change it. So now it will use banana implementation. So whatever banana or apple, we are passing it into fruit reference. Same thing, instead of creating this banana or apple object here, directly what I'm doing, do this. Now whatever class name you pass through command prompt, right, that class name object it will create. You pass banana class name or apple name. At runtime, it will take your class. Same thing I am converting into runtime. Enter your class name, fully qualified path. It is there in beans, right? Beans dot. I'll give apple. See what is executing now. Price is 200 and grade is A. Run it again. Enter your class name. Beans dot banana. Now it is executing price 100 and grade B. See your class, whatever the client class you implemented, your class is now independent of implementations. Correct? Your class is independent of implementations. The client class is now not having any direct fruit implementation dependency. I'm not or nowhere I'm using implementation class name. Directly, if you visit this class, I'm using only interface reference. I'm not using any implementation, either banana or apple or mango or whatever it is. The class names I'm not at all using here. At runtime, using this class dot for name, I'm creating an object and getting that into my interface reference, and using this interface only I'm calling these methods. So now your class become independent of implementations, right? Now this class is loosely coupled with fruits, loosely coupled with fruit implementations. This is what we call loosely coupled, right? Here I have a client class. This client class is loosely coupled with fruit implementations. Similar way, when you implement your API, right? When you implement your API classes should be loosely coupled. If you use directly that class names here, your classes will become tightly coupled. So for that reason, what you should do to achieve that, what you should do before implementing C class, consider if it is a Apple kind of class, or before implementing B class, you need to have a interface first here. You need to have a interface first here. So that for achieving this loosely coupled thing, what you need to do, first you need to create a interface, C interface, consider C interface. So the C interface you need to implement into this C class. Same way for service also, you need to have an interface here, interface, B interface, and you need to implement that B interface here. You need to implement that B interface here. And while injecting it, right, as Spring is having dependency injection feature, you should not use your class names directly here. Already we realized from that example, right? Instead of using class names, I have a class name C here and class name B here. Now B class needs a C class object. Okay. B class needs a C class object. For that reason, do you need to put C class name directly here? If I put C class name directly here, my B class will become tightly coupled with C class. You should not do this. Instead of this, as we have benefit or feature with Java, right? Parent class references we can put here. Use your C class interface reference here, C class interface reference, and put the setter method for that one. Now what you can do, though it is interface reference only, using your Spring, you can inject implementation object. C class object only you pass here, but maintain interface reference. Pass implementation object only, that is fine. Use interface reference here so that your B class object is not directly depending on C class. Your B class object not directly depending on C class. It is using always interface reference. Similarly, your A class also, right? Instead of having B class reference here directly, use your interface reference here, B class interface reference, and inject it using setter method or whatever approach. Now your A class is not depending on B class directly. Okay. So if I do this, what will happen? In future, if I discontinue this class, if I remove this class, if I delete this class from API, as I'm using JDBC, I want to continue with ORM. If I remove this C class implementation, it will not directly impact your B class, as you are not at all using any B class name here. I mean, B class is not at all using C class name here. Same way, if you want to discontinue this B implementation, if you want to delete this B class, delete it. It will not impact your A class also, because A class not directly using B class. So from this same example, whatever we did here, right? So I'm not at all using any apple class or banana class here. If you want to delete it, you delete it. It will not impact your client class. See, it is not impacting it. If you want to delete this banana, also delete it. It is not impacting it. So when it will impact, when you delete the interface, we generally will not delete interfaces. Interfaces are having actual required methods without implementation. So there is no need of deleting interface. So our class is depending on interface only, not on implementations. That's why you are not seeing any errors here. So we deleted with apple and mango and feature. In feature, if we get one more fruit here, one more fruit here, orange. You provide orange implementation. Implement orange, implements fruit. So now onwards, client will start using oranges. Now onwards, this client class can use oranges. Your client class is capable to accept any class because we are not depending on any class directly at compile time. We are giving our class names runtime. So now it started using oranges. You realize it, right? This client class is not at all depending on any fruit implementations. Similar way, your application MVC also will not depending on any implementations. So your A class, if it have B class reference, B interface references, it will not directly depending on any B implementations. Similar way, the B class, if it depend on interface, not on implementations. So whenever you remove this implementation classes, your dependency classes will not affect. Okay. So in Spring, what they are recommending is whenever you have dependency in another class, right? Instead of directly implementing your code in a class, first put signatures into interfaces, then implement them. If you go with this style, your application classes will become loosely coupled on each other. Okay. Once again, I'm saying instead of doing implementations directly, create interfaces first and provide implementations for your repository classes or service classes. So that what will happen, when you have a dependency of repository into services, instead of injecting your repository class name directly here, if you use interface name here, your service class will become loosely coupled with your repository implementations. Similar way, you into your controller, instead of using direct service implementation, if you can use interface references here, your controller class will become loosely coupled with service. So that's why if you follow this, we can say Spring is loosely coupled. If you don't follow this, your application will become tightly coupled with other classes. Okay. So we follow this approach, interface implementation approach. Create interfaces first and provide implementations. Create interface and provide implementations for your repositories and services, so that your MVC classes, controllers, will not directly depend on services. Services will not depending on repositories. Got it right? Any doubt so far?
No, Naveen.
Yeah, it's good, right? So
It is called means runtime polymorphism, right?
yes, this is runtime polymorphism. So this concept we have in Java itself. We are not specially getting this feature from Spring. Just follow this runtime polymorphism feature to make your Spring application loosely coupled. As Spring is providing this feature, right? In this client class, what I did using runtime class dot for name, I'm creating object. So this thing, this object creation, everything Spring is doing, and even I don't need this statement. I don't need to do class dot for name new instance. Just I need to maintain this class reference in my client class, and I need to provide one setter method. That's it. set fruit. So using this setter method, your Spring is capable to inject this object. So we can directly use that object in our methods. Okay. Same example, let us see using Spring. The same example to make application classes loosely coupled, right? Runtime polymorphism using Spring. Spring Beans runtime polymorphism. Build path, configure build path, add external jars, add your Spring library. Now I will create few packages here, form.ds.web for controller, service for services, repo for repositories. Okay, so this is the practice, right? Always when you start implementing a new application, we create three packages: web for controllers, service for service classes, repo for repository classes. And implementation will start from repository. Okay, from back to front we follow repository, service, and web. Now I want to implement something here, a repository. Okay, so I'm not going to implement a direct repository here. First you need to create an interface first here. Okay, so I'll create an interface called fuel. I'll create a interface name called fuel, and I'll put a method here, public void price, public void price with no implementation, as this is interface. Price and fuel name and price. So this, consider this is like a repository. Okay, you need to consider this is like a repository interface, a repo interface. I'm not doing any database operations, just to make you realize this runtime polymorphism. Now provide repo implementation. Okay, petrol IMPL, petrol IMPL class which implements fuel interface, fuel name and fuel price. Fuel name petrol and fuel price 100. So I have one fuel implementation here, petrol. Now I need a service, implement a service class. Before service class, right, you need to provide interface first. Engine is my interface. Engine CC, engine power and max engine CC and engine, what will have, torque. I have two methods in engine. So for this engine, provide implementation. Okay, something turbo engine, turbojet implements engine interface. So you need to provide implementation here. So engine CC, put some SOP here. So engine CC something 1250 cc, and torque something 180, torque or bhp. Consider this is like a bhp. So I have one engine implementation also. Now I have here car implement directly for this controller layer, right? Generally in implementation we do interface implementation model for repository service, not for controller. Controller is the last layer. We are not going to inject this last layer to anywhere. So repositories usually we inject into service, services into web. Web not going to inject anywhere, so that interface is not required. Because here this is not going to inject somewhere. We are not going to inject it into UI. This is not going to inject it anywhere, so that this for this one you need not to provide any interface implementation model. Just provide this for service and repository. For two of them must be enough. And here directly controller. I have a class here. I have a class car. So here I have a method public void start car, and this car wants to call engine. This car wants to call engine. So here you have turbojet. So now turbojet, engine CC, and engine torque I want to call from car. So you need to inject the turbojet here. I will use XML approach only. Okay. So turbojet. Now setter method set turbojet. Now you can call this jet dot engine CC, and you can call car. But we are using directly implementation reference. So your car class is tightly coupled. We will change it. Okay. Now this turbojet implementation here I want to call fuel. To start engine I want to call fuel. So you need a fuel object here. Let's say if you use petrol directly here, petrol implementation here, set fuel. So petrol implementation, I'm calling petrol implementation, fuel name, fuel dot fuel price. Now what is happening here? Into this engine class directly, petrol I injected. So engine class is directly tightly coupled with petrol, and your car class also directly using turbojet. So it cannot able to use another engine if it want to use. So I did tightly coupled architecture. So in case of tightly coupled architecture, you could not able to change them easily. If you want to change them, see what you need to do. So now here I'll create in my XML, right? Just create fuel class object first, bean ID, bean IDF, class name, beans dot petrol class. Directly if you want to inject, create petrol class. And we have one more bean called engine. Engine turbojet engine we have. Okay, packages are different, right? Form dot ds dot repo. Form dot ds dot engine is there in service. Turbojet engine. And we have controller. Form dot ds dot web dot car is our controller. Now car is having setter method, set jet engine, turbojet engine we need to inject here. So you know how to inject it. Here use property tag, call jet. You need to pass engine reference here. You need to pass engine reference E here. So now we are injecting this turbojet directly into car class. Now turbojet is having fuel dependency. Turbojet is having fuel dependency property fuel, and you can pass a reference F, fuel reference here. Now run the car class. Okay, we are loading Spring XML file. Try to get car object and get being car dot class. Now call car dot start car. So it is calling engine, and engine is calling petrol, and engine torque also we are calling. From the start car we are calling both the methods, start engine CC and start engine torque. So it is printing engine and fuel things. But here if you see your classes, this car class is tightly coupled with turbojet engine. In future, if you want to upgrade the engine, if you want to change the car engine from turbojet to some other natural engine, which is high in CC, if you want to upgrade it, there is a feature came into the market. There is an engine which is 1600 cc engine. I want to update to it. Or consider your car is having turbojet engine only, but engine wants to change the fuel. I have petrol engine. I want to add hybrid engine. I want to add electric also here. Instead of using petrol, I want to use electric. I want to discontinue with petrol and I want to continue with electric engine, or I want to continue with diesel engine. But if you see here, your turbo jet class is directly using petrol implementation here. So when you use petrol implementation, what will happen? If I delete this, I'm deleting it. Petrol implementation, I deleted. So as I am using directly that petrol class here, as I said, you should not use direct class names. If you use, see how many exceptions you are getting. As I'm using petrol implementation class directly, I'm getting this many exceptions. Now instead of that, what I will do here, do small change. Instead of using implementation, right, use interface reference here. Use interface reference PL. Okay, just change from implementation class to fuel only. Just change to interface. That's it. Petrol implementation I have. Into my engine class I'm using interface reference here and set interface method. Okay, so here also give this interface reference name only. Now I don't have any petrol name here. I don't see any petrol name here. So this setter method will accept this interface type. In my dependency injection, what I'm doing, into this set fuel, I'm injecting fuel class reference. Fuel class reference is what? Petrol. This petrol is implemented from this interface only. So wherever I have this interface dependency, in that interface dependency, I can pass any implementation object. So this is the petrol implementation object I'm injecting here into set fuel method. This set fuel method is accepting fuel interface. From this fuel interface only your implementation, petrol given implementation from this interface only, so that you could able to inject any fuel implementation here. It can be a petrol or it can be a diesel. Now try to run it. Go to application class and run it. just change it from direct implementation type to interface. Same thing is executing here. In future, if you want to delete it, delete this petrol implementation. No worries. There is no direct impact on your application. So if you are ready to provide new implementation, provide it. Diesel implementation I want. DIESEL diesel IMPL. Provide diesel implementation here. You need to implement fuel interface. Override fuel name and price. Since we deleted old class, we are adding new class here. Diesel price. Just go to your XML file. Here this class is we are discontinuing it. We removed it. So delete this petrol. Now just change here from petrol to diesel implementation. Just you need to provide new implementation, and that new implementation class name you should provide here. You need not to go to your classes and change it. You need not to go to your engine class and change the dependencies there. Your engine class is now perfectly independent of fuel. See this. Now onwards it started using diesel. So when I delete my petrol class, directly not impacting on my engine, because your engine class is not directly using any fuel implementations. Instead of that, it is using fuel interface. So when there is an interface reference, you comfortably inject any implementation. Here I have a setter method, set fuel. Into this set fuel, you can provide any implementation object. It can be a diesel, it can be a petrol, it can be anything, CNG or electric engine, whatever it is. Similar way, excuse me. Similar way, your car class also having dependency of turbojet. Directly we are using this turbojet dependency there. In case if I delete this turbojet, what will happen? If I delete this turbojet, it will show errors in car because directly you are using it. So directly you are using it. So what you need to do, instead of using this turbojet directly here, what you do, use its parent reference. Turbojet is having parent engine. So now here, change it. Engine, set engine. So instead of direct engine reference I'm using interface now. So you can execute it now as we have turbojet implementation, and in car class I'm using engine reference. So through XML file, you pass this turbojet implementation only here. This should work. See this is using the engine 1250cc, engine torque 180, and between this diesel it is using. Now in future, if you want to remove this turbojet, remove it. It is not showing any errors. Directly, it is not showing any errors in your car class because in car class, nowhere I'm using turbojet. Instead of that, I'm using its interface reference. That's why there is no direct dependency for me here on turbojet. So now instead of turbojet, what you can do, you can provide one more new implementation. Natural engine. So this natural engine also should provide implement from engine only. Engine CC something 1600, torque 250. Now this natural engine I want to use, which is 1260cc. what you need to do, you discontinue this turbo here, just replace with natural engine. That's it. From your car side, you don't need to do any change. Run it. Now engine 1600cc it is using with diesel, and engine torque is 250. See how flexibly we are able to changing these implementations. In case if you don't want diesel, provide new implementation, just change class name here. If you don't want this engine, provide new engine implementation and change the class name here. That's it. Your car is now not really depending on any engine, and your engine is not really depending on any fuel directly, as we are using their interface references instead of implementations. Car class is having interface reference, so we are able to injecting either natural engine or turbojet engine. Similar way, your turbojet or natural engines, they are using fuel interface, so they are depending on fuel interface only, not on implementation, so that you can provide any fuel implementation, either diesel or petrol or any other fuel. This way you can make your application layers loosely coupled. So in this example, what we realized is repository classes directly not depending on services, and service classes not directly depending on any controller classes. Using interface implementation models, we make them loosely coupled. Now car is independent of any engine, and engine is independent of any fuel. Correct? This way we implement our controller classes, service classes, and the repository classes. Real examples we will see. Okay. The same fashion I will follow. Interface implementation models. You need to follow the same model only to make your application layers loosely coupled. If you make this way, right, so in future when you want to discontinue existing classes, that will not impact on any other class. So when you have one class dependency in another class, when you class one class dependency in another class, instead of using that class direct dependency here, use its interface dependency. So for that reason, what you need to do, instead of providing direct implementations, you have few repository methods like save, update, delete. Instead of implementing them directly first here, put that method signatures into interface, then provide implementations, so that in future if you want to discontinue with these methods and with this class, you can discontinue and you can provide new implementation that will not impact on the dependency classes where we are using interface dependencies instead of implementation dependencies. Are we clear? So this is what runtime polymorphism is. Using this runtime polymorphism, and by using dependency injection feature, what we are doing, we are making our application layers loosely coupled. Okay, controllers not depending on services, services not depending on repositories. All three layers become loosely coupled layers. Are we clear?
Naveen?
Yes.
Yes.
Yeah. So yeah, that's what. Yeah, that's what we say. Loosely coupled. So in interviews, if they ask what is loosely coupled, we can answer this. Instead of using implementation objects as a dependencies, if we can have a interface references, we can make the two layers as loosely coupled. It's a simple core Java feature only. Okay.
I mean, this will not come under Spring feature, right? This is the core Java feature only, right?
Yeah, core Java feature only. You need to follow that. If you follow that, yeah,
We have to.
your application classes will become loosely coupled. Because as we have dependency injection, right? If we can if we can follow this interface implementation model, as we are using this dependency injection advantage here, your application become really a loosely coupled application. Even if you want to do any changes also, you go to XML and do the changes there. That's it.
Yes.
At runtime, it will use new classes and it will inject them.
Suppose that
Okay.
class is not present, which we are trying to create here as a bean. It will
Then
throw
class not
error
found. You will see. Yeah, class not found errors you will get usually.
at compile time or runtime?
Runtime. So if I pass something XYZ here, no problem. But at runtime, it will try to create object. It will say XYZ is not there. I don't see any compile time errors here. You will see runtime errors. Okay. Yeah. So it's basically simple runtime polymorphism. Okay. We follow this style. Okay. This is very important. Okay. Looks like simple, right? But this is very important to follow during implementations. Few will follow who knows about this pattern. Who doesn't know, they don't follow this. But whoever follows this approach, right, that application will become really loosely coupled application. When there are changes will become easy. It will not impact other layers. You no need to go to other layers and do many changes, because here we are seeing one single class only is having dependency. Consider here this class is having 5-6 dependencies. Okay, or your fuel class, this diesel implementation using in 5-6 classes. If you inject this diesel in 5-6 classes, if you delete it here, what will happen? 5-6 classes will impact when you use it directly. Instead of that, if you use its interface, when you want to delete and provide new implementation, it's okay. Delete it and provide new implementation. It will not impact other layers. Okay. So this is the style that we should follow. So when somebody asks how you will provide implementations in Spring, you need to say first we will provide interfaces for repositories and interfaces for services, and then we implement them. And while injecting into service implementations, we use repository interfaces to inject them. Similar way, service interfaces we use in controllers to inject service implementations. Okay, so that the layers will become, controller and service layer will become loosely coupled, and service layer and repository layer also will become loosely coupled. So flexible layers, that layers will be flexible. Something if you want to remove and if you want to add new, you can add it. Okay. So if you see in real time, let's say if you buy a CDMA phone, usually we used to have in 2000s Reliance CDMA phones, there we used to use the same SIM whichever they provided. That phones are tightly coupled with that network provider. Nowadays we are buying GSM mobiles. There we can insert any SIM card because they are not directly depending on any SIM card. We can purchase any provider SIM card and we can insert. Whereas in CDMA we don't have that approach. Similar thing. They need to provide a common interface to allow any implementations. Okay. Yeah, going forward also we follow the same patterns. Okay. We know to worry. If you don't understand, we'll discuss. But still, it is a simple example, right? A simple core example. You must understand.